Okay, actually, points for the whole room. Points for the whole room. On the AP test, it's very common to see something like this. And something I've been joking with people about is the following. I feel pretty certain that in your previous math classes, you have often heard the teacher say, oh look, this has, like there's two ways to do this. And what you typically do is you ignore the teacher and just wait until he says, but this is the best. And then you just copy that. Like you don't really care about the other method. Who cares? I just want to know the best method. That's what a lot of students do. This class is very different than that. When I say there are two ways to understand something, that's because they're going to test you on both ways. Or they're going to test you one of the two and you don't know which one. So you have to know both. So it's really common to have something like this on a test question. And this can mean two things. Please raise your hand if you know both meanings of this symbol. This thing right here has two meanings. You must understand both of them. Let's go, Kylie.
Is it a point or an interval?
Okay, so you have to know that when it says 1, 2 in parentheses is either the point x equals 1, y equals 2, or it is the interval from x equal 1 to x equal 2. How many knew both? Point 2 for Kylie. Questions so far? Then we'll get to Canyon's question. Okay, oh please.
Will the interval always, like, they can both be in parentheses, right? Like, you don't have one that has to be bracketed. Okay.
Yeah, that's the problem, Carson, is that this exact symbol has two meanings. And that's why you have to read very slowly to make sure you understand the context of what you are reading, so you do not get mixed up between point and interval. So do not skim. Don't just pick things from a problem. Like I get upset when people start picking at the problem. Like, don't pick at it. Just read it, okay? Okay, interval. This is Canyon's question. If the interval is from x equal 1 to x equal 2, and it is an open interval, that just means we are going to start at an x-coordinate that is slightly more than 1. And then we're going to continue to all x-coordinates until we come to the x-coordinate that's infinitesimally less than 2. That's what open interval means. Does that answer your question?
Yeah.
Closed interval means start exactly at 1, go to exactly 2. Good question. Other questions? Josh?
If it's closed, it will have the bracket versus the
Correct.
parentheses.
So closed interval will have
Oh,
brackets.
yes.
And they can split it. One end can be closed, one end can be open. Questions? Awesome. Just a reminder, do not sit passively in this class. Make sure every concept makes sense to you. If it doesn't, just talk about it until it does. That is the key to the test, okay? This says, let the function be such that f double prime is less than 0. Okay. That is an extremely common clue to appear on an AP question. Raise your hand if you know exactly what that clue is telling you. Keep your hand. Who knows exactly what that clue is telling you? That's going to show up a lot. So let's go, Luke.
That f prime is decreasing and f is concave down.
Okay, how many knew that? Point, 2 for Luke. Okay, so here we go. Danica's chart. It's a little bit smaller. So we know that because f double prime is negative, the y coordinates of f double prime are negative. The y values of f prime will decrease, and the curve is concave down. Okay. Something they really like to test you on is, do you clearly understand the meaning of the word concave down? Like more than just the general shape. Here's the meaning of the word concave down. Listen close, make sure you understand it. Once you understand it, if necessary, make a flashcard so that you will never forget it. Okay? If a curve is concave down, so here we go, concave down. this is concave down and increasing. The same applies if the curve is concave down and decreasing, or both, doesn't matter. This little d here has significant meaning. It's telling you that as you read the graph, so this would be the graph of f, as you read the graph of f from left to right, and you check slopes of this graph. For example, maybe you come way down here, and you say, I want to see what the slope of this graph is at this point. This graph, it gives us a point down here, 1.1, comma, 4.18. So let's draw a line there. So that's decent. Like if I want to know this tangent slope, okay? If I move across the graph, moving to the right, then I move from this tangent slope to, say, another tangent slope. Let's go up to, say, this one at x equal 1.2. The y value here is 4.38. If the curve is concave down, then the green slope, bad drawing, the green slope, worse drawing. Hold on, come on, Brian. Decent. The green slope must be more than the pink slope, because right here the D means that as you read the graph of f from left to right, from tangent to tangent, you must have a decreasing pattern. Question. Okay, it's also true that if you throw in some secant slopes, like we put a secant slope right here, in fact, points for the whole room. Raise your hand if you can answer this question. Is the tangent slope here, they're all positive slopes because they're slanted upwards. Is the slope of the green greater or less than the slope of the black? Raise your hand if you know. Don't overthink it. Is the slope value, the value of the green slope, going to be more or less than the value of the black slope? Just look at the picture. Let's go, Sydney. So the green slope is definitely more than the black slope. How many knew it? Point. 2 for Sydney. That's what this means. That if f is concave down, then this d is telling you, as you read from left to right, from this tangent to this secant, that must be a decreasing sequence. See one more? We've got the black and we've got the pink. Raise your hand if you know which has a lesser slope. We've got the black, we've got the pink. Which has a lesser slope, Lauren? Lauren, sorry.
Pink.
How many vote pink? Point. 2 for Lauren. I hope that's obvious. Like, I'm taking time to make sure you see it, but I hope it's clear. Any questions? That's what the D is telling you. Okay? Let's keep reading the problem. So every time they identify a curve that is concave down, that doesn't mean they're testing you on this idea. But they do test on it fairly commonly. Okay, so selected values of f are shown in the table above. That's a key thing to note. Whenever you see a table, do not assume what's happening between the points. You don't have any idea what's happening between. Just all you have are those points. Which point must be true about this? Okay, here's something they test on a lot as well. That symbol has 2 meanings. You must know the meaning. You must know both meanings. Who knows both meanings of this symbol? What are the 2 meanings of that symbol? You have to know both of them. It will test you on both meanings. Fewer names on this one. Sorry.
Points variable.
2 points for that. You're just mixing that up with this idea. How this can be a point, and this can also be an interval. This is different. No worries. Who knows what this means? Abby?
The y coordinate of at
could write that down. We could say we have the graph of f prime at x equal 1.2. There is some y coordinate. That y coordinate can be symbolically represented as f prime of 1.2. It's definitely the y coordinate on f prime. See, for Abby, how many knew this? Point. What is the other meaning of this? Ken? So, don't take points if you don't raise your hand. It's the only way I can tell if it's like something that's you're not getting or you're getting. So this is definitely a problem. Not knowing this is going to cause you to miss, I don't know, half the questions. Okay, so if you're not remembering this, make sure you make a flashcard to remember it. In fact, what I would do, if you're not remembering, is I would just use this as an example. Sorry, just leave the card. I would just use it as an example. I'd put on one side of the card f prime of 1.2, and then a question mark. And then the other side of the card would say the y coordinate on f prime at x equal 1.2. Also, the tangent slope of the f graph at x equal 1.2. Like, the key to the flashcards is you're not memorizing this the night before. You're trying to make this a permanent part of your memory.
What's the second thing?
First one is, this symbol represents the y coordinate of f prime at x equal 1.2. It also represents the tangent slope of the f graph at x equal 1.2. And I might throw into my card as well the tangent slope, comma, derivative, comma, or rate of change of the f graph at x equal 1.2. That would be an even better flashcard. So this also means the tangent slope or derivative or instantaneous rate of change of f at x equal 1.2.
On derivative and what?
So one more time. So it also means the tangent slope or derivative or instantaneous, I would just abbreviate INST, instantaneous, rate of change, I'd abbreviate that as well as just ROC. Also has some other abbreviations. What does that stand for? There you go, that's right. I knew it was something else. Rate of change. Yeah, whatever, you know. Of the graph of that at x equal 1.2. Good questions. Anybody else? My son was going to check out lines.
Or F, or F.
So this symbol represents, on the graph of f, tangent slope, derivative, or instantaneous rate of change of f at x equal 1.2. Yeah, my son's going to a checkout line at Walmart. He has on a hat that has the Vans logo. And the guy's like, oh, you must really like math. What? He's like, oh, look, it says on your hat, square root of the answer. Yeah.
Oh, that's good.
Yeah, square root of the answer.
That's good, right?
Yeah.
You never know. You know, people like joke. They like this stuff really wander around Cougar Stadium. You guys must really like calculus. Wow. So, all these calculus fans. Yes. Okay. Everybody understand what this means?
Yeah.
Awesome. Raise your hand. Which one are they testing you on in this problem? Are they asking you to think about the y coordinate of f prime? Or are they asking you to think about the tangent slope of f? Like, which one do you think they are testing you on, and why? Like, how do you know? They're testing you on one of the two, otherwise they wouldn't be asking you to talk about f prime of 1.2. So which one are you being tested on? And how do you recognize that's what you are being tested on? Marin's halfway in, now halfway out. Go ahead, Marin, what do you think?
I was thinking the tangent slope because the table is a left.
Perfect. No, your answer is correct and your reasoning, even more important, is correct. Okay? They're giving you a graph of F. So they don't seem to be talking about the graph of F prime. They're talking about the tangent slope of F. And big hint, most of the time that's what this is talking about. Okay, you do need to know both meanings, but more heavily they're talking about the tangent slope of F. How many knew it? Had your hand ready? Point, 2 from Aaron. Okay. So they're talking about the tangent slope of F. I would make another flashcard. It's up to you. You don't have to make these. I just don't compel anyone to do anything other than don't talk when I talk. It's really fun to me. Otherwise, I try to let you have your agency. Okay. I would have a flashcard. This one's a bit complex. On one side of the card, I would construct a small, simple table. Just something to remind me that I'm looking at a table. So this is kind of complex. I probably wouldn't draw this one. I just draw something simple, but a simple table. And I have a question mark, because I'm trying to remind myself, what should I be remembering about tables? Fair? Flip the card over. I would have item 1. Tables only show selected values. Tables only show selected values. Watching Lizzie's like this. Put a lot on your head there. Continue your life. Number 2. Can't find a tangent slope from a table. Can't find a tangent slope from a table. At this moment, I don't remember anything else that's crucial about tables, but you have a card now, so if you need to add to it, we can. Cannot find a tangent slope from a table. So Marin said, hey, they're asking me to talk about f prime of 1.2. My logical thought is they want the tangent slope of f. My flashcard memory jumps to life and says, wait a minute, I remember the card. It says, I can't find a tangent slope from a table, but I can find the secant slope. So I'm going to find secant slopes, see how they're related to this tangent slope.
Should we put like on the flashlight, like can find secant
Sure.
slope?
It goes with the other one. You can't find a tangent, but you can find the secant. So, raise your hand, please. What is the abbreviation SS? Please don't ever use that on a written answer, but for scratch work, it's perfectly fine, secant slope. What is the secant slope of this graph of f from x equal 1.1 until x equal 1.2? Secant slope means change in y over change in x. How much does the y value change from here to here compared to how much the x value changes? We got 0.2 here versus 0.1. How many 0.1s fit into 0.2? Okay, so this secant slope is 2. So now I know something definitive about this tangent slope. Read my mind. What do I know about this tangent slope right here for sure? So hands, I gotta get you thinking with me, not just a few people. Like you need to think with me. This class is not about copying. That will become abundantly clear on Thursday. Okay? What do I know about this for certain? No doubt whatsoever. Dawson.
It's greater than 2.
This green slope has got to be more than 2. Otherwise the curve would not be concave down. How many knew it? 0.2 for Dawson. Question. I just keep going. Let's go find this secant slope. So come up here. This is x equal 1.2. 3. Y coordinate is 4.56. You don't say it out loud, please. Just raise your hand if you can tell me the change in the y coordinate. The change in the x is easy. Looking for help? Go, Chris.
It's 0.1 or 0.18, so 1.8 over.
You got so with this, so that secant slope has a value of 1.8. I mean, knew it before you said it. 0.2 for Chris. So, hey, another thing that happens a lot on the AP test. Okay, I cannot demonstrate to you how to solve the problem because you're never going to see this one again. But if you can learn to kind of think in a logical sequence, you're going to be fine. So here's my logical sequence of thoughts. As I read the problem, I first noticed that I am talking about a graph of f that is concave down. As I keep reading, they want to know about the tangent slope of f. I remember the flashcard. Oh yeah, can't find tangent slope. I can find secants. I find them, and another flashcard springs to my mind, which is, oh yeah, what does concave down mean? It means as I read the graph from left to right, I must see a decreasing sequence. So now I know what I need to know about this pink slope. This right here is the tangent slope of f at x equal 1.2, and I know something about this pink slope. Raise your hand if you know something about the pink slope. What do I now know for certain, absolutely no doubt, about the pink slope? Josh? This pink slope is greater than 1.8, otherwise the curve wouldn't be concave down, but also less than 2. We knew it before we said it. 0.2 for Josh. We want to take this question, let me show you, in the pink packet alone. Problem 26. Problem number 23, problem number 20, problem number, hold on, 32. All of them, in one way or another, test you on this idea as to what is meant by concave down. They all do it in different ways, but they are one concept. That's why for the AP test, you don't try to understand 4 problems. You try to understand one concept. Then you can solve 4 problems. Please.
Wait, so concave down is always decreasing, right?
We have to say it a little more
Oh.
detail, but you're right. So if f is concave down, then as you read the graph of f from left to right, and you follow the slopes, secant slopes, tangent slopes, or both, you must have a decreasing pattern. Yeah. We wouldn't say concave down means decreasing. That's too simple.
Yeah.
Is that okay?
Yeah.
Good call. 2 points.
What if you have like the other half of the, because the point is still being,
So let's show that real quick. So watch. Here's what Josh is talking about. Points for the whole room here. Make a big gigantic one. It makes it easier to see. Okay, there's F. Now let's be fun. Let's call it H. That was exciting for the kids. Okay, so here's H. H is concave down. Okay. Somebody last period got a little wound up. And they're like, "No, it's good. It means you're passionate about calculus." I'm like, "Yeah, I ain't passionate about calculus." But no, it's true. I'm not. What I get really excited about. Okay, I hate mundane learning, like with a passion. Like to just stand up here and say, "Please do this. Now do this. Now copy what I do." Oh my gosh, I'm quitting at lunch. Okay, I'm not waiting until tomorrow. Like it's the pits. But when I get the feeling, and I think I can trust the feeling, that you are gaining understanding of something, Like, you are seeing how it works. I don't get excited because you're going to go use it somewhere else. I get excited because once you know what it means to understand, you can learn anything. But you have to understand. You can't just copy. That's what I get excited about. That's why I broke my head. Did I tell you the story, right? Oh, quick story. Quick story. So I feel that I can lay legitimate claim to being the most passionate teacher on the planet. Like, I think you'd have to look a long ways to find somebody who got more excited than I got in class one day. So about 3 years ago, I started to get that feeling of, these guys are really understanding. Like, you're really learning. You're not just copying. You are learning. And when that happens, I get so excited. And if the class is really with me, like, the class will start to get really quiet, and you're all eyes are here. Everyone's like focused. They're like hardly looking at what they're writing. Like, really, because like just really into the learning, right? And I have known to do the following on occasion. When that moment occurs, I will wait just till everybody's like really focused. And I go, yes, and I'll like smack the board really hard with my palm. It's really cool because the whole room just like rocks back in their chair like 2 feet, like just like a wave. Like the whole room just brought, and I was like, whoa. One time I scared the girl right here so bad. Like, I hit the board, I turn around, she's on the floor. Like, her foot, like, I'm sorry, I'm going to help her back to her chair. So this day, like, I'm getting really excited 3 years ago, January 25th-ish. I don't remember exactly. I'm getting ready, I can just sense it. I can sense the moment. Like, everybody's with me, and they're ready to just like turn to the board and go, good job, and I'm super excited. For some unknown reason, I was talking about a problem where I like to refer to, you kind of have to use a brute force approach here. You just have to really muscle through. And so I made a fist, and like brute force. In the back of the room, Sydney Waite, Allie and Gracie Waite's older sister, she's like, yeah, brute force. Like, just kind of herself like this, just following along and getting real excited. So instead of going like this, I don't know why in the heck I did this, but I literally turned. Okay, I am not a small person typically. All 200 and whatever pounds, lean into the board. Like, take a full step. Like, I played football, you know, it's like, bam, like just as hard as I can. Like, I hit the board like this, and I went from excitement to just utter shock. In like a half a second, I'm like, ah. And the class like, you just broke your hand. I'm like, that looks all right. Like, can I limp over here? Like, ah. They grabbed it. I'm like, where's the pen? And I put the pen like this. And I'm like, let's keep talking. It just hurts so bad. I was going to pass out. I'm like, oh, I got to sit down. So I sit down in the chair for a minute. Go to the doctor. He's like, okay, who got you? Who'd you get mad at? He says, you have what's known as a boxer's fracture. Because it comes from punching things. Okay, he says, so what'd you get mad at? I was like, I didn't get mad at all. I was just really excited. What? Like, how'd you get excited? Like, I was in my class at school and I just got really excited. And he's like, what do you teach? I'm like, calculus. Oh, that ain't possible. You got mad at somebody. You know, some other guy's going to show up with a broken nose or something. No, it broke the bone right there. Yeah, and ever since, the hand recovered pretty well, but you can tell, because like this hand, the fingers still spread. This one won't. Like the pinky won't open. Yeah. So I had the X-ray if you don't believe me. So. Okay, sorry for the diversion. So I feel very, I have evidence. I do get excited at times. Well, try not to hit the board anymore. That was a bad day. It's a good story, but a bad day. The whiteboard is made of like plate aluminum, like that thick. You ain't breaking the whiteboard. You hit it with a bat, it breaking the whiteboard. You hit it with a hammer. It's very thick. Yeah, never mind. Okay, focus. My bad. That was way too much of a diversion. Look, Okay, the question was, if h is concave down but decreasing, please notice, if I find a slope right here, just say it out loud. Is that slope positive or negative? Negative. Negative. That slope has a negative value. If you go from left to right, and we like make a secant slope, is the value of that slope positive or negative? More or less negative than the green? More or less negative than the green? More negative. So as you read the slopes from left to right, are the slopes decreasing in value? Yes. This line is becoming steeper, that's different. But the value of the slope is decreasing in value as you go left to right. That's what concave down means. Concave down means that as you read, so if f is concave down, as you read the graph of f from left to right, you will find that the tangent slopes, secant slopes, or any of them, like alternate them, tangent, secant, decreasing pattern. Has to be. Three questions on the test, pretty sure it will test you on that idea in 3 different ways. Please.
So did you just know that it was an increasing concave down from the table?
So I knew for sure concave down from the clue. I actually don't know for certain increasing because tables only show selected values, but I'm having a hard time imagining a curve that is concave down where these all do go up. I can't picture anything else. So I think I'm pretty safe.
Okay.
2 point. Are we good? Any other questions here? Next question. Stop that.